We'll move objects around in some more interesting ways soon enough, but first we need to talk about how you in code can find references to various game objects and their components. And first what we're going to do is we're going to take our cube and our sphere and remove the script component from both of them. And we're going to create a new standalone game object, which I'm just going to call, what do we call it? Just game manager. I'm just calling it manager. It'll just be a generic object we attach our script to. It's not going to serve any other purpose, just to hold our script, which I think is more appropriate for scripts which are just general logic and not concerning particular individual objects. That is my stylistic preference. Anyway, so now we have this manager with the my script, and go back and I added in this code in the start method where first off we're using this method find object of type. And that is actually a method of it's a static method of the object class. Again, be clear, this is Unity engine.object, which has a static method find object of type. Visual Studio is hinting to us by the fact that this is a slightly different shade of teal here. It's hinting to us, we don't actually need that because it knows what we're talking about, because we're inside the MyScript class, which inherits from model behavior, which inherits from behavior, which inherits from component, which ultimately inherits from Unity engine.object. So we don't have to qualify this static method with its class name. It knows what we're talking about. And anyway, this method, what it does is it finds all objects of a particular type. And when we specify the type, you pass in system.type values. And to get such values, we use the type of operator, and here we're specifying the game object type. So we want to find an object of the game object type. And this method always returns an object regardless of what we're looking for. So no matter what we're going to fetch here, in this case a game object, as far as the compiler knows, we're getting back an object. But because we know at runtime what's going to be stored in O here is going to be a game object, we can then just immediately cast it to type game object. And of course we can just sort of skip that step. We don't need to make these separate lines. I was just trying to be explicit for clarity. So we just need that one line, and that's all good. So now we have a game object retrieved by this method, and we're going to log it out by printing out its name, because every game object has a name. Actually, the object type is where the name property comes from, but then game object inherits that. And that is the name that is what we see here. So this game object has the name sphere, this has the name manager, this has cube. The question though is, what game object here are we going to get? Because in our scene we have 5 of them. And the answer is, well, you just get one of them, and you're not in control of which one you get. Frankly, I'm not sure why this method even exists. It doesn't seem very useful to me. Slightly more useful, there is find objects of type. That's plural objects. And this returns an array of object instead of just a single object. And again, in this case, we know we're going to get back an array of game objects, specifically, not just object. So we can do the cast here, and that's more useful because now we can use them like game objects. And we're going to loop through them and print out all their names. So now if we run the code here, let's see what we get. First off, find object of type manager. So for whatever reason, it's this last one. I guess because it's one that's loaded first. And then find objects of type, printed out manager, sphere, cube, directional light, main camera, all of them. It just printed them all out. So those are 2 ways we can get at references to objects. But one thing we're probably going to want to do different here is there's another event method called awake, which I don't know why Visual Studio adds the private modifier there. I don't think it matters at all, but it would only matter if for whatever reason we wanted to call this awake method from some other class of our own code, but I don't think we would ever want to do that. Anyway, I'll just get rid of it. There we go. Anyway, so the awake event is like start. It's called when an object is created for the first time before any update's called, but it's guaranteed that at least within an individual frame, all the calls to awake will be done before any call to start. What's useful about that is we can do scaffolding business where we hook objects together, like get references to things and initialize fields to store references. We do that typically in our awake methods, and then our start methods, we can assume all that stuff is already done. So it generally would be more appropriate to do all this business in awake rather than start. Another method we have for getting references to objects is the find method, which is a static method of the game object type. So be clear, our MyScript class doesn't inherit from game object. It's a component, not a game object. They both inherit from object, but not game object. So we have to write explicitly GameObject.find, and it's expecting a string. What did we have in our scene? We had manager, sphere, cube, directional light, main camera. So just one of these names as a string is what we want. Let's just say directional light, just to demonstrate that you have to get the name exactly right with the right capitalization and all that. So that looks good to me. And this returns a game object. We'll just call it light. There we go. And just to prove that works, we'll print out find. We'll print out the name of the object. There we go. Let's see this in action. I will restart the game. Where does it say at the end? Yeah, under find, directional light. That got logged. Okay, so that works as we expected. And if you're wondering, if we specify a name that doesn't exist, like we make a typo and make that lowercase d, now it's not going to find it. So if I restart, we get a null reference exception, because what happened here is that light got assigned null, and then we tried to access its name property. And if you try and access the property or methods of things that don't exist, that are null, you get a null reference exception. Another thing to keep in mind is that we might actually have multiple objects with the same name. I'm going to duplicate our sphere here and rename it so it also has the name sphere. And then I'm going to move it so that when we print out its properties, we can see that distinction. Okay, so now go back here and we're going to search for sphere. And just so I don't confuse you, I'll rename this to sphere, though it doesn't, of course, doesn't really matter what the variable name is. Sphere, there we go. And we're going to print out its transform. And so what we should expect is, well, we know we're getting back something named sphere. That part is not going to be the surprise. The question is, which sphere do we get? And the answer is, well, when you call find and it searches through all of your game objects, it's just whichever one it encounters, which happens to have a name that matches, that's the one you get. So it's also basically just indeterminate from our perspective which one we're going to get. We'll get one of the two. So let's see which one we get. I'm going to play this one here. And, oh wait, it didn't print out the transform. Oh, excuse me. Local position. There we go. We want to print out just the position, not the whole transform. There we go. 002.1, 3.8. Which one is that? Is that this one? 2.1, 3. Yeah, it's about that one. So it's this sphere that we happen to get, not the other one. If you're looking for stuff by name, you probably want to make sure stuff has unique names rather than just relying on happenstance. In addition to having names, our objects can also have tags. That's what this is about up here. And by default, there are 6 tags we can apply. These just come stock. I don't know if you can even remove these existing tags. But you can also create your own custom tags, as I will do here. I will call it my tag. If I can type, whatever, my tag, lowercase tag. There, so that's a new tag that's been created. And now when I go back to an object and I want to apply a tag, I can choose my tag. The thing to keep in mind is that this tag system is not like other tag systems where you can apply multiple tags to one thing. A single game object can only have one tag. Quite inconveniently too. It'd be nice if you had a proper tag system where you could have multiple tags per object, but that's not the case. So having applied my tag to sphere, if I come here and select respawn, well, now it only has that one tag, not my tag anymore. So you only have one tag applied to any object. So let's put it back to my tag. I'm also going to make this cube, give it my tag. And now if in our code, if we want to find, let's see, I'm going to duplicate this code real quick. Let's see, I want to find with tag, and it's called my tag, lowercase t. I'll just give it the same name. Doesn't matter, just for clarity. We'll just print out the name this time. Let's see which one we get. It could either be the sphere or the cube. I don't know which one we get. It's indeterminate. It turns out, okay, we get the sphere. But keep in mind, the cube also has the same tag, but just for whatever reason, when it looks through all the objects with that tag, it found the sphere first. Now, if I want, I can also find all objects with a particular tag. If I simply here, I'll just copy. And what is it? It's find objects with tag. I believe that's correct. No, what's going on? It's called find game objects with tag. It's very confusing. Why did they change that name? And that will return an array of game objects. And so we'll have another loop here. Oh, and also I should make sure this is find with tag, because that's what it's the result of. We're printing out to console. And as I come back here, play the game, and let's see. So find with tag sphere, but then find game objects, plural, with tag. It finds both sphere and cube because they both have the tag called myTag. So that's what we expected. Strangely, why does it have, I noticed in the code completion, it said game object with tag singular, but I didn't see that in the documentation. So what the hell is this thing? Oh, it doesn't want an array. Go back to tag. Is that proper now? Oh, well, we don't want to reduplicate that declaration. What the hell is this? Is this any different from find with tag? Because I don't, strangely in the documentation it's not mentioned. I guess they decided at some point they needed to make this symmetrical. Though honestly now it's more confusing because it's really easy to look at this and accidentally see this and vice versa. I assume that's just here. Let me actually see this in action. I assume it's just going to do the same thing as find with tag. Oh, I forgot to print that out just once, of course. So myTag, excuse me. Okay, that's what I meant to do. Come back here, play. And so find with tag gets a sphere, find game object with tag also gets a sphere rather than the cube. I assume they're exactly equivalent. It's weird that it's not mentioned in the documentation. Anyway, so those are probably the most essential methods for getting references to game objects. But understand, finding by type is very expensive, not something you want to do every frame. Finding by name, bit better, but still quite expensive and not something you want to do every frame. So those things you probably should only do on startup when your initial game objects are loading up. Then it's appropriate in like your awake methods. Otherwise, particularly like in an update function, you wouldn't want to call that stuff. Finding stuff by tag can be fine though. That's relatively optimized because of how I believe it keeps a hash table to pre-existing arrays that it can just hand a reference to when you use these methods. So finding by tag, much more efficient. So I hope that gives you an idea of how we can hook our game objects together in code. Though of course what we're missing here is that probably what you want to do is in awake, you want to preserve references to these objects that we're finding. So let's say we just want to find a reference to the cube and the sphere, and we want to preserve that in our class. So we can create some private fields, which are game objects here. We'll call just one cube. We'll have another one for the sphere. And what we'll do is upon awake, we'll just store in sphere what we get back from game object.find sphere, and then we'll also do the same for cube, but assign that to cube, and we'll get rid of all this other stuff. And that should be all we need. Because assume just for whatever reason in the script we're going to make repeated reference in other methods to the cube and sphere that we find on awake. So this is how we can hook them up programmatically. But sometimes what you might want to allow is for objects to get hooked up in the editor. Like you define some component type that needs to reference certain other objects. Rather than making those connections in the code, I'm going to actually get rid of these lines here. And we're going to make these public. And what happens when we give our script component public fields is if we then go into the editor and here look at the manager, which has the MyScript component, it now has here cube and sphere. It has places where we can plug in hooks for some cube object and a sphere object. And here I'm just going to specify cube, and here I'm going to specify the sphere. But actually, nothing's stopping me in this case from assigning sphere to the cube field and the cube to the sphere field because they are valid game objects. That's the only restriction here. It has to be a game object. So now when the scene is loaded and the manager game object is created, its MyScript component is going to be initialized with the sphere for its cube field and the cube game object for its sphere field. That's just going to automatically be hooked up for us by Unity. We don't have to do so programmatically. And in fact, what we can do is we can give our component public fields of other types, like say just some float field here, which we'll call Fred. And now if I go back to the manager and look at a script component and wait for the recompile, now you see, hey, there's a Fred component, and what I can plug in here is just any float value. So this is how our scripts can be configured much like the built-in component types, where in the editor is where you specify the initial values for certain public fields. And again, that might be very handy for certain purposes where, like, say you want to create some component type which your environment designers are going to use, and you don't want them to have to go into the code to hook up certain values. You want it to just be specified in the editors. So that's what this opens up. You can create custom components and have their instances configured directly in the editor. In fact, be clear, any game object can have as many instances of any script component as you want. So I'm going to give the manager a second script component. Oops, it didn't like the drag there. There we go. Okay, and so this one, the cube, I'll make actually cube. And then the sphere here, well, I'll make a main camera for whatever reason. Doesn't matter in this case because our script does nothing. But anyway, and then now the Fred value in this component can be whatever I want. It can be totally different. So be clear, associated with this one game object are two script components of the same type, but they are separate instances of this one class called myScript. And each one has its own cube field, sphere field, and Fred field, which are configured independently here in the editor.